A story that starts with a spectacular rainforest butterfly. The bright blue of a morpho butterfly shines out like a beacon in the rainforest. It can be seen half a kilometer away. Exactly what the butterfly wants: to attract a mate. But the wings of these butterflies contain no pigments. They produce color in the same way that soap bubbles do. These shimmering colors are caused by light being reflected from the outside and inside surface of the bubble and change with the angle of viewing. But the color of a morpho is far more intense than a soap bubble. And the reason is down to the microarchitecture of each and every tiny wing scale. The morpho uses these colors for display, to make itself conspicuous. And it's certainly been noticed by scientists. At Exeter University in the United Kingdom, they've been examining the morpho's microarchitecture down to the finest detail. Each scale is covered in ridges, and each ridge is made of layers of cuticle. These layers are separated by a distance that is the same as the wavelength of blue light, and so when sunlight bounces off each of these layers, only the blue light is reflected back. And the exact spacing of the layers means successive waves of blue light interfere with each other, reinforcing themselves and intensifying the color. To make it easier to see what's happening, the Exeter scientists then built a model of this structure that will work with microwaves that have a much longer wavelength than light. And what they found was that the gaps in the ridges on the wing scales are structured in such a way that no light gets trapped. It's all reflected, which adds to the brilliance of the color. It's hard to believe that there isn't a single molecule of pigment in these scales. Japanese manufacturers have incorporated these ideas into fabric, material they call morphotex, made up of nylon and polyester arranged in the same way as the layers of cuticle in a morpho's wing scale. Morphotex shimmers with interference colors that will never fade, and cosmetics companies are already developing lipstick with the same effect. But the morpho's lesson is even more profound. Each scale is, in fact, a photonic crystal, a device that can transmit light, the optical equivalent of a transistor. Transistors revolutionized electronics and powered the computer revolution. Photonic crystals could power a new information revolution of even faster, more energy-efficient optical computing. And nature might well be able to point the way. With this new way of seeing the world, the possibilities are endless. Modern technology has already created a whole range of new materials based on nature's examples. But sometimes nature is still one step ahead. Spider silk is an extraordinary